Assalamualaikum everyone. Today we are going to present our CSE 106 project. The title of our presentation is Empirical Time Complexity of Linear Search and Friendship Graph using Undirected Graph. Our group members are Mustafa Sarah Taslim, Rifat Tamanna and Zarin Taslim. Introduction of Linear Search. First, we will talk about linear search. Linear search checks each element of an array one by one until the target is found. The theoretical time complexity of linear search is big O of n for both average and lowest cases. Our main goal is to experimentally verify either the practical performance matches this theory. Methodology of linear search. To do this experiment, we implemented linear search in Python. We tested the algorithm on arrays of different sizes from 10,000 to 50,000. For each array size, we generated random values and performed 1,000 searches with random targets. Then we calculated the average execution time and plotted a graph of time versus input size. Python implementation. This slide shows the Python function for linear search. The function goes through the array using a loop. If the target value is found, it returns the index. If the target is not found, it returns -1. This simple implementation helps us observe the real performance of linear search. Simulation result of linear search. Here we can see the simulation result. As the array size increases, the average execution time also increases. For example, when the array size doubles, the time really doubles as well. This shows a linear relationship between time and input size. Graphical result of linear search. This graph clearly shows a straight line trend. The average execution time grows proportionally with the input size. This visual result strongly supports the idea of linear time complexity. Thank you. Now I would like to call Rifa Samana to continue this presentation.
I would like to take this opportunity to continue the presentation. From our experiment, we can conclude that the execution time increases linearly with input side. The empirical result matches the theoretical complexity big O n. So linear search behave exactly as expected in real practice. Now we move to part B1, which is about a friendship graph. We simulated a social network using an undirected graph. We tested graphs with 500 to 2,500 users. Our goals were to calculate vertex degrees, verify the handshaking theorem, find connected components, and plot the results. Now, methodology. We used an adjacency matrix to represent the graph. If two users are friends, we put 1 in the matrix. The degree of a vertex is the total number of friends. We used the handshaking theorem, which states that the sum of all degrees equal twice the number of edges. Connected components were found using the DFS algorithm. This slide shows how we generate a random undirected adjacency matrix. We ensure symmetries in the matrix so that the graph remains undirected. The edge probability P controls how dense the graph is. Here we used a Python function to verify the handshaking theorem. We calculate the sum of all the vertex degrees, then we compare it with 2 times the number of edges. Both values matched perfectly. After that, next slide. This function calculates the degree of each vertex. It simply sums each rows of the adjacency matrix. This helps us understand how many friends each user has. Now I would like to hand over the presentation to Sarah Tasmi.
In this slide, we used the deep fast search algorithm. DFS helps us explore the graph and count how many connected components exist. Each component represents a separate group of users. For this table, we can see that as n increase, the average degree increase. At the same time, the number of connected components decrease. For the largest graph, the network becomes fully connected. This graph shows how connected components change with graph size. It clearly demonstrates that higher density leads to better connectivities. For each for every graph, we verified that the sum of degrees equals 2 times the number of edges. The error was 0, which means the theorem is perfectly satisfied. To conclude this part, we successfully built the undefined friendship graph. We verified the handshaking theorem. We analyze connected components and graph density. This experiment shows how graph size and age probably affect connectivity. Thank you everyone for listening to our presentation.